Welcome to NPTEL. Myself Dr. Jayanto Das from Department of Metallurgical and Materials Engineering, IIT Kharagpur. I will be teaching you advanced materials and processes. Last couple of classes you may recall that we have discussed about different properties of nanomaterials, and among those properties one of the very interesting properties were the mechanical properties, because reducing grain size always increases the strength of the materials. Now, on the other hand, there are several functional properties that can be exploited and can be achieved only in nanomaterials, and definitely the engineers always look for exploiting those properties for real life application. And already today we are using this nano material for a large number of various technological application. As on today we call it as nanotechnology. So, today we will be focusing mostly on the functional aspects of nanomaterial along with the nanotechnology, which the property cannot be achieved in any other materials. As an example, I can tell you, like we have studied about quantum dots. So, how these quantum dots are so much important for any kind of emission of some range of spectra, and that can lead to a better resolution level in a screen. Okay. So, these are some of the very important aspect of nanotechnology. Or let us say, if I wish to produce a surface where usually we sit down on a chair, or maybe the surface of a big building, okay, the outer wall surface, can we make, let us say, the wall surface in such a way that there will be no water seepage through the walls. What I want to mean, like if I put a drop of water on a lotus leaf, then the water never stick to the leaf. You have noticed that. So, it immediately goes away on the leaf, and the leaf appear very fresh and so on. So, can we prepare such kind of lotus effect on any other surfaces? So, it requires some sort of mimicking the nature and the features in nanoscale, which can be adopted on some other materials that engineers produced by several processing technique. So, before we begin all this discussion, let us have a close look on what are the smart behavior of materials can be achieved in different types of material. I am not at all concentrating in this slide on nanomaterials. So, like here the first one is the input, and the second column representing the output. We can achieve color change in several class of materials by application of temperature, which we called as thermomonochromatics, then radiation, let us say photochromatics, and mechanochromatics like deformation, means I deform a material and then color has changed. Okay. So, these are very unique smart behavior of some materials, or maybe some chemical reaction goes on and it changes the color. Okay. Or electrochromatics, and let us say liquid crystal, here we employ some electric potential and which causes a color change, or let us say suspended particle, here we provide a electrical potential, it causes a color change. Or maybe the rheological properties of material can be changed by application of some electrical signal. So, here we apply electrical potential and it simply changes the stiffness of the material. So, these are very important properties in terms of let us say chromics, photochromics, thermochromics or mechanochromics, chemochromics or let us say electrochromics and so on. On the other hand, there are large range of material behavior that is linked with output of light, means it emits light, and you must be knowing what we have discussed in the earlier class, that a large range of material that absorb light and then it cause fluorescence and it emit light. Okay. However, those kind of light emission may have some time lag from the absorption stage to the emission stage. So, in that case we call it these properties as luminescence. So, electroluminescence or luminescent the material where we apply some electrical potential and then it emit light, or maybe photoluminescence, here we apply some radiation that absorb let us say ultraviolet ray and then it emit a optical light. Ultraviolet ray has a higher energy level, h nu the photon energy is very high and then it emit let us say a lower or a larger wavelength. So, it basically absorb a lower wavelength and it emit a larger wavelength. Now, very similarly chemoluminescence or thermoluminescence, this is very interesting property. If we increase the temperature of the material, then it emit lights. Or let us say one of the very interesting phenomena or smart behavior of materials, that is light emitting diode, we call it as LED. LED. So, here we apply a electric potential and then it emits actually the light. So, today we will try to look at what are those properties we really need, or let us say in a photovoltaic cell here we absorb sunlight and then we generate a electrical potential and that can be stored in a battery which can be used later on when sunlight will not be there. So, this is a very unique property that we used in many remote places as a photovoltaics. On the other hand, the type 3 behavior of smart behavior of materials are interchangeable, means any of the signal input signal we give, we get the output, or if we give electric, then we can get deformation, means if this signal is given, then we can generate the first column signal. So, here you already know about piezoelectric material, where we provide deformation, means mechanical straining, then it gives us a electrical pulse, and if we apply a electrical pulse, we can get a deformation. Or let us say pyroelectric, this is another important, means we apply temperature, it produces a electrical signal, or if we apply in the reverse way electrical signal, we can increase the temperature. So, you can use in a heating stage, or maybe thermoelectric, or maybe electrostatic, or let us say magnetostatic. So, so these are the electrostatic properties, and where we apply electrical potential and deformation, these interchangeable properties are very much important. Now, the question comes, I mean if we try to apply or achieve such properties in nanomaterial, is there any change of their behavior? Okay. So, that is basically one of the very important points, and we will be starting with our discussion on these nanomaterial on smart behavior like solid state lighting. Okay. So, usually the bulb what we use, we have a tungsten filament, we apply a potential and there is a thermionic emission, but here it is a quantum dot, and so the diode, when we apply a very low voltage, it emits light. So, we apply a electrical signal and it emit light. So, this is one of the very interesting point. So, how people develop this idea that a quantum dot and let us say the quantum light emitting diode can be achieved in a nanomaterial. Here quantum means you understand that the size is below 100 nanometer, and the quantum or the electrons are constrained in all these 3 dimension actually. So, the first evolution was the LED, that is called light emitting diode, and light emitting diode has a shortcoming that is called narrow sets of emission frequencies. So, if you just look at a solid state physics where we discuss mostly on p-n junction, here we have a semiconductor and a p-n junction appear here. This is the p type and this is the n type, and in between there is a barrier. Okay. So, if we apply a reverse bias, then the barrier width increases, means if I apply positive bias in this side and negative bias in the p side, then all these electron and hole, they goes to the opposite direction and then increases the barrier region, because the negative charges n type, they basically attracted by the positive and the positive one is attracted by the negative one. Okay. So, this is a very standard phenomena that everybody knows, but if we apply a forward bias, means there is a positive side goes to the n type and the negative side goes to the n type, then what will happen? They will repulse each other, and so the barrier width will decrease. Okay. And if we put basically a metallic contact here, then the light will be emitted, and this is a property called electro luminescence, means we apply a potential and the light will be emitted. So, the energy input that at the junction that basically creates a voltage output which causes the fluorescence property. On the other hand, when we talk about quantum LED, so the quantum dot layer, these are the quantum dot layers. Okay. So, with different color. So, the different color mean basically RGB. Okay. So, red, green and blue. So, these red, green and blue, they are printed one after another actually, again RGB. So, in that way actually it continues. Now, here these are the layer which creates this whole blocking and transport, where the electron transport is caused by this layer. So, one side we have a cathode and another side we have a anode, which is deposited, the whole structure is deposited on a substrate or let us say a glass. So, this is a typical cross section of a quantum LED, and yes, quantum LED is the advanced version of LED because of its emission frequencies, which is much wider than the LEDs. However, the life of quantum LEDs are not extremely great. So, it is something like 1000 hour or so, and so they are in competition with another new technology that is called OLED. So, OLED is the organic LEDs. So, they have a larger life. But anyway, the phenomena here about the quantum LED is directly linked with the nanotechnology, because we use quantum to produce and emit the light. So, some of these quantum dot and their images, people can have a look. What you can see here, that the quantum dots in the form of quantum LEDs are made of network of quantum dot and can also be built by printing. So, I can take such kind of printing technology, where red QLEDs are printed first and then the green LEDs are printed in the second line, and then the third, then I print the blue one. So, I get continuously R, G and B. So, here you can see that we have red, green and blue, okay, one after another. So, this is a typical this is a very small scale actually. So, 1.2 millimeter, and inside the structures are appeared as such kind of very small quantum dots. So, quantum dots of nanometer size crystal, they are basically semiconductors silicon and germanium, for which the electronic properties are strongly dependent on their size. The principal and the potential advantage of these QLED is that the efficiencies are very high and better control of the emitted light, and the most important are the form factor characteristic, and on the other hand quantum LEDs has a higher amount of lumens, means it emit a higher lumens of light with respect to the wattage that has been consumed. So, the effectivity or conversion of energy from electrical signal to the optical signal, that factor is much better. Okay. So, here also another quantum dots I show you, these are the quantum dots grown on indium, gallium and arsenic. Each dot is somewhat in the range of 20 nanometer. So, wide and 8 nanometer in height. So, these are some very important quantum dots and important things. Now, in case of LCD, that is liquid crystal display, we also have a large amount of application of the nanotechnology, and these LCDs can be used in very large size as transparency control technology for, let us say, privacy window. Let us say I want to create a window that will be transparent, as well as if I wish, then it will be completely blurred. Okay. So, I wish to control by some other kind of signal the transparency level of a window, and this is impossible without nanotechnology application. So, how to do that? So, there are this is a liquid crystal display typical. So, when we do not apply any voltage, the light is transferred through this, and if we have a filter, then we get a polarized light. But once the liquid crystal layer with a twisting crystal and polarized light path, let us say by application of some particular voltage or let us say some signal, then we can get actually cross polarized filter. So, basically the direction orientation changes here. So, we get another direction of the polarized light. So, this is called the liquid crystal display, or we can use as a suspended particle display SPD, and there is a very similar effect where we have rod like or molecule with a very strong dipole. Here is the positive side and this is the negative side. Okay. So, they are randomly oriented. So, if light is going to pass, then they will be blocked, whereas if we apply a potential across this barrier, then they will be aligned, and if the light goes in, then light can be passed. So, this is a very interesting phenomena, that suspended particle display that could act as a transparent or non-transparent in windows, and they are electrically activated, but can change from a very transparent or clear state to a opaque state. Okay. So, and vice versa. So, the typical device has multiple layers, and this active layer is associated with a color change, consists of this kind of needle shape particle that is suspended in a liquid. So, if no voltage is applied, then particles are randomly positioned, but if we apply some and in that case actually it become opaque, but when we apply a voltage, then they are aligned along the direction of the application of the voltage, and these needle shaped particles imposes field and light can easily pass through it. So, this is somewhat a very nice example of the nanotechnology. So, two of this nanotechnology what we have discussed, like a QLED or let us say the LCD and SPDs and so on. Now, the other application areas that we can in real life we use, that let us say like a hydrophobic or hydrophilic surface. the hydrophobicity or hydrophilicity that depends on a liquid and on a solid and their angles. Okay. So, if the angle is greater than theta greater than 150 degree, we call it as a super hydrophobic surface. Okay. So, this is a surface which is super hydrophobic. So, the liquid droplet has the same shape, but if the wettability is improved or higher, then this angle actually decreases. Okay. So, this angle is let us say greater than 90 degree. So, then we call it as a more wettable surface, but highly wetting surface that has a theta that is lying in the range of 0 to 90 degree. So, this is called as a hydrophilic surface actually. So, here this is like water can be more attracted on some surface. So, you should keep it in mind that not all time we need a hydrophobic surface, so that the water should not be wetted on a surface, but some cases application we also need water to be wetted on a surface. So, these important application areas one has to look at. So, if we look at a such kind of hydrophobicity, then you can see this is water droplet appear in such a way, even though it is not a super hydrophobic, this is a normal hydrophobic surface. And in a more nano scale, if you look at this kind of hydrophobicity, how it achieve in a surface, we have very small nanoscale feature on the surface, where there are some air pockets. So, air can go in, which basically protect from wetting of the surface. So, like if we think about a lotus leaf, okay. So, lotus leaf has this kind of features. Okay. So, these kind of nanoscale features, and if you put one drop of water, then not only it basically remain its shape like a sphere, but it also collect the dirt from the surface. You can see these are the dirt particles. So, nanoscale dirt particles that goes into the water droplet, and it clean the surface. So, we can use this particular feature or mimic this natural feature, so that we can produce a surface for a lotus effect. So, the particles which is lying on a surface, when a water droplet falls, then it automatically roll and it collect those particles. Whereas, this is a typical hydrophobic surface. So, hydrophobicity and typical hydrophobic surface, which basically says that once the liquid droplet falls, then immediately it basically forms a sphere. So, this is a typical feature, and then it collect all the darts and give you and pick up the darts to have such kind of lotus effect. Now, if we want to produce a surface which has a easy cleaning material, and it should have some sort of antimicrobial features. So, in that case we need hydrophilic surface, so that if there is a dirt, then the dirt is sticking on a surface and the water goes and absorb on the surface, and then the dirt will decompose, and once the light appear, then the water molecule goes away and then the darts will run off. So, this is another technology that can be used using let us say titanium or zinc oxide nanoparticle that are coated on a surface. Okay. So, there is a nanoscale coating on the surface, and exposure of ultraviolet radiation. So, electron hole pairs will be created in the material. So, the free radicals or electron that react with the foreign substance. So, let us assume these are the foreign substance that is sticking on a surface, and so due to the light rays and on the coating, it produces some positive and negative hole pairs. So, they will assist to decompose by oxidation of those harmful particles on the surface. And so, the loosened and decomposed particles that can be washed away during a normal rainfall. So, every 3 months or 2 months there will be rainfall, and so these particles will go away. So, this is one of the very interesting feature that we can easy cleaning surface we can create, which may have some sort of antimicrobial feature. So, also we can produce some textile, means our shirt and let us say some of the chairs with seats where there will be no microbial activity. So, in that case also the textile that can be widely sought. This is a image of a textured nanofiber. You can see this is a length scale of 200 nanometer. So, where catalyst and antimicrobial compound can be sprayed on the surface, so that it can provide those kind of features. So, this is another interesting thing, and so whatever different nanotechnology I have discussed, we can simply take an example for a automotive, okay, which is widely very wide industry on today. So, so several components of a automobile can be replaced using nanotechnology, and which is already adopted so far by the bigger companies on today. So, from an industry perspective, the all time people wish to improve the overall performance of driving and the comfort. So, these are the very prime objective, and we can simply start with putting some nano composite here, which have a very high strength as well as some shock absorbing capacity, and we can replace those kind of normal fluorescent lamp with QLED lights, which will consume less power. So, we can increase the efficiency, as well as we can increase some magnetorheological shock absorber and electrorheological tires, which will give us more effective properties. Those functional properties can be, as well as if there are scratches, it is very hard to remove. So, why do not we produce some sort of anti scratch paint of using nanotechnology, which will cause self healing, or maybe some self cleaning very clear type of sprays can be made on the top of a car, and then all the water droplets, when it will fall, immediately it will collect the dirt, and it will the car surface will look very shiny as it newly appeared. So, that can be done. So, self cleaning, or let us say there are seats inside. So, those seats could be antimicrobial textiles. So, this is somewhat very much important, and biothreat sensors or alert, air purification, many sensors we can use for using this nanotechnology. Let us say some of the emergency medical health monitoring system can also be given in a car, or the screen itself is very much important aspect of a car, and we can use these self cleaning glasses or anti fogging glasses, and many electrical or mechanical components, emission control, batteries, supercapacitors, tribological application, let us say wear, lubricant, nano coolant. Okay. So, here we have a coolant, right. So, inside a car, and so those coolant can be, we can use some nanotechnology for that. So, this is a very wide range of application areas that one can think about, as well as people always from an industry perspective think about the safety requirement. So, from such kind of nano composite or frame and shells we can use for improving the car performance. So, improve energy efficiency using let us say such kind of LED lights, we can reduce the energy level or the consumption. At the same time we can reduce the weight by high strength materials, improve advanced electronic control system, improve durability, reliability and cost efficiency. So, these are somewhat the most important and challenging aspect on today for nanotechnology. However, many of these aspects that I told so far to you are already under application. Okay. So, they are very much interesting. So, the nanotechnology is not restricted within only let us say the field of metallurgy or physics, but it has widely spread over biotechnology and so on. So very wider spectrum of application of these nanomaterials, where chemistry, physics, analytics, materials science and biology all are involved with the technical know-how of these particular sets of material, where we can exploit the properties in terms of coating, emulsion, dispersion, plastic, film, powder. So, you can see the many and the end product could be used in automotive components, paper, cosmetics, textile, display. So very wide range of application, and we need a large future developments for complex formulation of those material. Embedding of nano into a matrix could be a key issue for generating maximum added value, as well as for material, nutrition and pharma, energy, electronics, biotechnology. We can think about all these different types of application, including OLED, sensor, contrast, UV protection, heat management, self cleaning, and so these are the new product resulting from this nanotechnology. So, you can see the spectrum of the application areas, product development. So, there is a large opportunity and of these nanomaterials and nanotechnology. So, engineers should think about and devote themselves for developing this material for the human benefit. And since these materials are metastable and advanced alloy, so we must think about this matter. Thank you very much. We will continue the discussion on a new topic in the next week.